3.6 to my multiplying fractions. I do multiplying fractions.
All right, so you guys, thank you, Dominic. The reason it's 3.6 and 3.8 is we combined 3 lessons into one. Essentially, we are multiplying fractions. You already know multiplication is repeated addition. You already know what a product is. Cross-reducing, we'll come back to in a moment when we get down to some examples of it. You guys now know that any whole number can be written as a fraction, right?
Yes.
You simply put that number over.
1.
We'll come back to that too in a moment. The rules for multiplying fractions are pretty cut and dry. Multiplying fractions involve multiplying the what by the what? And then you multiply the... So top number by top number, bottom number by bottom number. If you ever get common denominators, I will take a point off. It's not actually wrong, but it's a waste of a step, and it just increases your likelihood of getting something wrong because you start dealing with bigger numbers. So when multiplying fractions, you simply multiply it. The top and the top, the bottom and the bottom. Do not get a common denominator. Number 4 is our examples. So when we did this problem, or when we did problem number 9, you guys multiplied 5 by 3 and 9 by 4, and you all got 15 over 126. I think actually every single one of you got 15 over 126. I don't see all the eyes up here. And then I said, is that your final answer? And every single one of you said, yup. You failed to realize that 15 and 126 have a common factor of 3. So really the reduced form of the answer, which is what we're always looking for, is 5 over 42. So then I introduced this trick to you called cross-reducing. And we said the same problem, 5 over 9. These are the exact same problems, 5 over 9 times 3 over 14. But cross-reducing involves looking at opposite numerators and denominators, right, Joe? So if I look at the opposite numerator and denominator here, 5 and 14, Joe, can you reduce 5 and 14?
No.
No, they don't have a common factor. But Joseph, can you reduce 9 and 3?
Yes.
Because what goes into both 9 and 3, Joe? 3. So 3 divided by 3 gives us 1. 9 divided by 3 gives us 3. And now we multiplied with simpler numbers, yes or no?
Yes.
5 times 1 is what?
5.
And 3 times 14, a little more challenging, but better than 9 times 14, right?
Yeah.
So 3 times 14 is?
42.
So that is the exact same answer. It's the exact same problem. And we didn't even have to think about reducing, yes or no?
Yes.
Number 10, then I just gave it to you. I said, here's your problem, go. All of you now are like well versed in the fact that you can never, ever calculate with what?
Mixed numbers.
So you all converted into impropers. Most of you cross-reduced the 20 and the 5 because they have common factor of 5. Your answer was an improper. Can you ever give an answer as an improper?
No.
So you converted into a mixed. The last thing that happened here was we had a word problem that you needed to write your own problem for, and not Suleiman, but Manuel did a good job of writing the problem. He converted 3 1/2 to 7 over 2, right? But the number 4 is just a whole number. But because I think, and I don't know if you guys feel this way or not, it's easier to multiply by fractions if you have a numerator and a denominator. We just took that 4 and we turned it into 4 over 1, which we talked about way back in note number 2, right, Adam? I should be up here again, I say. So then 4 over 1 times 7 over 2, there was some cross-reducing here. We got 14 over 1, which is an improper, and the answer was what?
14 hours.
Any questions?